In this video, I'd like to tell you about iron on the moon. So remember the issue with iron then, as we sort of said in an earlier video, that if you have like a planet or moon that was forming like this, I'll draw some heavier elements like iron sort of in blue. And I'll draw some lighter elements like maybe the silicates in green. So maybe this is the silicon right here, the silicates, whatever you want to think of it as. And this here would be something like the iron, the Fe iron. And feel free to look at the periodic chart to review the symbols right there. Okay. So what happened is then, of course, this process of differentiation happens, where basically what that differentiation means is heavy things sink. Okay, so what happens then is as heavy things sink, then we'll get a, whatever you want to call it, the planet or the moon, where we're dealing with here, where the heavy things sort of made it to the center and the lighter things sort of stay on the outside. And this is very much the picture of the Earth that we have. The surface that we live on is definitely rich in the silicates, the lighter things, and we think there's an iron core in the Earth. And so the theory of ejection, which is how the moon formed, and we're sort of saying that something came in and collided with the Earth and took a big bite out of it like this, took a big bite, and this big bite went out here, and that's sort of what formed the moon. Okay, and so in that picture here, you might think, well, the moon should be really rich in silicates, because when the object that came in hammered the Earth, then this big section of the surface was likely ejected. That would happen on the moon here. That would where the moon formed. So the moon should be very rich in lighter things, in silicates, which it is. But there is some iron on the moon, but there's something very interesting about that as well. Okay, so here's a map of where the iron is on the moon. Okay, so it's all in some false computer color, and it's just, you can see the scale down here where blue is essentially no iron and red is sort of like 14% iron, or about as rich as you're going to get. So on the front side, you see a bunch of iron in places like this and this and this. On the back side, almost nothing, a little bit more, and maybe some right there. But I'm just going to stop for a minute here. Do you notice anything about where the iron is on the moon? Well, if I just go trace again here, maybe in, well, not blue, maybe in purple. These look like some ears. This looks like a head. These look like a couple of feet. In other words, yes, the iron basically exists where the Maria are. You go right here. Here's the iron map I just showed you. Here's the Maria. I mean, you just have a pretty good one-to-one correspondence. Even the bunny ears there and there. Little spot right there. It might be that spot right there. But it looks like the iron sort of always exists where the Maria is. Now, why would that happen? Well, as we said, let me go back a couple slides here. As we said, we think that if iron made it to a planet or a moon or something, then the iron would be very deep because it differentiated. Well, how does the iron, which is really deep, get up to the surface? In some sort of volcanic or lava activity. So if here's the core here and the iron's down there, the only way this iron's going to get to the top is if, well, it indeed came to the top, maybe in the form of some volcano exploding and ejecting it like that. And so we always said, right, that's the only way to get something from the inside of a planet or moon up to the surface is through some volcanic activity. And so we always said that the Maria was these dark basaltic regions right here. But where do they come from? Lava flows. And where does lava come from? Well, lava comes from volcanoes, right? Lava. Volcanoes. And where does that come from? Comes from deep within. And so maybe that's how the iron got there. So I certainly don't know how the iron got there, or maybe when this catastrophic event happened on Earth, when this big blammo happened, maybe the Earth wasn't fully differentiated yet, and there still was a lot of iron mixed near the surface. I don't know that, but in either case, this is the picture. So the iron on the moon, which it really shouldn't have, exists all in the Maria, evidence it came from deep within during those lava flows that happened on the moon. So a little bit of common sense in there as well. Okay. And lastly, then I'll just say, well, why do the front and back sides look so different? We've been hammering this point for quite some time now. Remember, we always see this side of the moon, and here's the back side. It looks so alien and wasn't even seen until 1959 and that kind of thing. Well, the story sort of goes like this. Suppose you have the Earth here, and you have the moon here, and suppose the moon was already tidally locked. In other words, it already had this T orbit equals T rotation, that was set. So what would happen then is sort of if you can imagine then this side of the moon here sort of becomes the close side to the Earth, and then this side over here sort of becomes the far side, okay? And what you might imagine is because this side here is closer, the force of gravity is going to be a bit larger, is going to be largest on this side of the moon than, say, relative to over there. So in other words, you have this half of the moon where ever since tidal locking has been closest to the Earth, so the gravity is stronger on it. And so what may have happened in this region here is the gravity here might have caused cracks and weakness in the moon's crust, because the gravity force is kind of strong only on this near side, which remember always persisted because the moon is tidally locked. So there's this one side that's always facing towards the Earth and always feels the stronger gravity. And so maybe this side of the Earth was always a bit weak, and that of course allowed lava to flow out because of the cracks and the weakness in the crust. The lava flowed out, hence the nature of all this area. All the lava flow was on the surface of the moon that was closest to the Earth. The backside, gravity a bit weaker, crust could be a bit stronger, there were not as many cracks and weaknesses and so on, and so not as much lava flowed other than just a few weak spots right there. And so there's really a great asymmetry in the look of the moon. The front side looks nothing like the backside and vice versa, and that might be why.